notes are, does it come up? There we go. 7.B.1 notes, it says Intro to Conics sections and graphing parabolas. We'll get to the graphing more so on Monday, but for today the main objective is what is this thing called the conic section and what's so special about parabolas in that process. So if I was to take a cone, like imagine even an ice cream cone, that shape where there's a start, the circle on the top and a point at the bottom, if I instead turn it upside down and I make it so that two cones kind of point together and they're meeting at their one point, that would be called something called a double napped cone, where you have two cones kind of stacked on top of each other. What we do is when you take a double napped cone, you can slice it in different ways and it'll create something called a conic section, a section formed from a cone. Right? So this plane here shows if I cut right through it across like this, it'll form a shape. So there are 4 shapes that are formed from conic sections, and they are listed right here: circle, ellipse, parabola, and hyperbola. And so a circle can be, one of the ways that you can form a circle is if you take a plane or like a sheet of paper and you cut just horizontally across, it forms this shape right here, which is a circle. Okay, if instead you do it kind of slanted, you start up at the top here and you come slanted across, that comes an ellipse. The next one is if you take it again angled across from the top to the bottom on one of the cones, that's a parabola. We've seen that before, first semester. And then finally, if you go slice straight from the top to the bottom for this double nap cone, you'll get 2 curves that kind of look like 2 parabolas, but it's actually called a hyperbola. And we've seen hyperbolas last week in 7A, in the last few weeks with 7A, when we were studying inverse variation, that was hyperbolas. So we're pretty much done here. Now we're in the unit with parabolas. In Unit 7B, we'll talk more about what's so special about parabolas, specifically in terms of their shape rather than as a function. We're not going to do ellipses actually in this unit at all. You might see it again at some point if you ever take another math class. And then we'll finish up 7C will be circles. And then we'll kind of put it all together in Unit 7D. So that's kind of what's coming ahead. Right? So now we're going to really focus in on parabolas. Ignore the other guys for right now and really talk more about parabolas. So it says right here at the bottom, recall that the graph of y equals ax squared is a parabola with vertex 0, 0, and axis of symmetry x equals 0. That was back in Unit 2, first semester, when we learned about parabolas as functions. Anytime we had a parabola that was opening up or down, we knew that it had a vertex. The parent function had a vertex at 0, 0, and always had an axis of symmetry at x equals 0. Well, now, because we're treating parabolas not as functions, but instead as conic sections, we can take our parabolas and open them right, left, up, or down. So they can open in any of the 4 directions. The main objective here is that some of this is the same, where there's still a vertex. That's that first piece. There still will be the axis of symmetry. I'm going to draw that straight down. It's usually as a dashed line, and it cuts your parabola right in half. The 2 new parts of this parabola, though, are something called, like this point here. You'll see this point sitting inside of the parabola itself. That's called a focus. So it's a point. It's a new vocab word. You've never heard of that before, probably in terms of parabolas. But it's a focus is going to be a point that's inside of the parabola, and we'll see what's so special about that. You also might notice this line here. There's a horizontal line a certain distance away from the vertex. That's called the directrix. So the directrix and the focus, those are 2 new words about parabolas that you may not have known before, and we never included them before in our diagram, but now it's going to be part of my parabola. All right, so the main objective here, again, I have a vertex, I have a focus inside of it, I have a directrix a certain distance away, and then an AOS. So there's going to now be 4 different things that we draw on parabolas to make sure we have it fully understood. All right, so if you notice here, though, it's showing you that this distance from the focus to the vertex is the same from the vertex to the directrix. That's what these little tick marks are showing. And any point on the parabola, so not just the vertex, but if I look at this point, and I measure that distance, it's always the same. Both those distances exactly the same. So it says here, on any parabola, each point is equidistant from a point called the focus and a line called the directrix. All right, now I was going to do like a little demonstration. I did that kind of second hour too, but instead of walking you through it, I'm just going to show you kind of what ends up happening, where you can create your own parabola if you have some kind of like wax paper or tracing paper. What you do is you start by creating a horizontal line across. Let me move this out of the way for a second. So you see this horizontal line at the bottom where I've labeled that my directrix. So all I did was draw a straight horizontal line called the directrix, and then I picked a spot any distance away. I picked a little dot and I called it my focus. So I plotted a point here. And you can try this out yourself at some point if you wanted to. Then what your goal is, you take your paper or tracing paper and you just keep folding so that the line and the focus meet at, like if you look at this diagram here, this could be one of the folds that I could do because this line hits that dot. It's hard to see because it's obviously see-through paper, but I kept doing that and I kept folding the paper more and more and more, about like maybe 10, 15 folds, until it was kind of clear that I could draw my own parabola through the folds, kind of like the best parabola that I could fit through there. So I did that parabola. Then I knew that the vertex has to be at the bottom of that parabola. This is the lowest point there. So there's my vertex. Then we have our focus, which again was the point I started with, just the point I started with. And then the distance, what I did here was I just picked a point on the parabola. And I measured with a ruler the distance from that point to the directrix was like almost an inch. Then I measured directly from the focus to that point, still an inch, right? And then I could do that with a bunch of different ones. I can do from this point to the focus is almost 2 inches, and then straight down again almost 2 inches. So it's the same exact measurement no matter what point I pick on my parabola. That's what the whole point of what parabolas are. Right? So instead of doing that demonstration, I just wanted to show you that. Let's get to now, though, how to tell which way a parabola is going to open. It can open up, down, left, or right. All right, so on the bottom here, this little table, there's a column for x squared equals 4py and y squared equals 4px. Basically what that is it's just the generic form for a parabola. It's going to be one of these two. Either x will be squared or y will be squared. We're used to seeing x squared before today, but we didn't really notice this 4p stuff before. It was usually just y equals x squared, but now we have to figure out what that 4p is going to do. Same thing here, the y squareds, we have to figure out what is that going to do to my graph and what the 4p will look like. So if p, and p is the distance from the focus to the directrix, or from the, focus to the vertex, or vertex to the directrix. So it's that distance is p. So if p is a positive number, right, that's what that p greater than 0 means, and x squared, it's got an x squared in it. That's going to be an example that looks like this. X squared equals 12y. I just picked a number. I just picked 12. You can pick any number at all as long as it's positive. This example, anytime you have an x squared with a positive number, is going to open up. All of our parabolas will sit at 0, 0, and so we just have to figure out, is it opening up, down, left, or right? So this will open up. All right, so that's our x squared with a positive number. And then in addition to the parabola itself, I want to also include my focus. So just pick a dot anywhere inside that parabola. You can go up as far as you'd like or close to the vertex as you'd like. And then the same distance away the other direction, instead of another dot, I have to draw a line that's horizontal. Because horizontal lines can't cross my parabola, they won't touch it. There's just a straight line horizontally. And the only other thing missing here is my AOS. So I draw in an AOS going up and down. Alright, same idea, but if my p-value, that's what the hole punch kind of cut off here, p is less than 0 means p is negative. If instead I have a negative p-value, or the negative in front of y, where the number is, and I have an x squared, so the example here could be x squared equals negative 12y, I instead will have a parabola that opens down. So this will open down. And we put a dot at 0, 0, and you make it opening down. All right, and then again, I want to include my AOS, directrix, and focus. So focus down here, a little bit up higher again is my directrix, which is a horizontal line because it can't touch the parabola. And we'll do more with the graphs on Monday, but for right now, it's just an introduction of what does it even look like. and then an AOS cutting the graph in half. All right, then we have the other two. So these ones are a little bit more familiar. We did them first semester. On the right side, we have y squared. Whenever it's a y squared equation, you instead will have graphs that open left or right. So when it's a y squared with a positive number, for example, y squared equals 8x. You can't have two of the same variable. If y is being squared, then you have to have an x for the number after it. That's going to open right. So we make again, start at 0, 0, you make a parabola opening to the right. All right, then you have to include the focus and the directrix, same distance away. Okay, and the last thing is the AOS again, all four things included to get full credit eventually when we get to graphing. Okay, so far we've seen up, down, and right. The last one is opens left. Whenever you have a graph that has a y squared in it and a negative number. So it'll be equal to a negative, say, 8x. These are just examples. Yours could be different. I'm just picking any numbers that are positive or negative, and then either x squared or y squared. And so let's put it at 0, 0, and have it opening left. And then you put your focus down anywhere you'd like for now. And then we'll pick the directrix again. These directrix, though, are vertical lines now for these two because they can't, again, touch the parabola once the parabola is opening either right or left. And then finally, your AOS, cutting the graph in half. So again, on Monday, we'll talk more about what is P, or what will it tell me in terms of where to plot the focus and the directrix. For today, the goal is, can you just identify which way a graph opens, left, right, up, or down? And then could you find P? Once now that we know our equations here, we'll be able to find P by dividing by 4. Okay, so once everyone's good here, we're going to go to the next page. All right, here we go. It says at the top, just a quick summary. Well, we just found out that any parabola that will have an x squared is going to open up or down. If it's an x squared with a positive number, it's opening up. If it's got a negative number, it's opening down. All right, parabolas with a y squared open right or left. Again, same idea. Parabolas that open right will be positive, and parabolas that open left will be negative. So we're going to look out for x squared or y squared, positive or negative, to help us determine what each one is. The only thing you have to be careful of is make sure your x squared or your y squared is isolated. That means they have to be completely alone. Can't have numbers next to the x squared or the y squared. The other variable can have the number attached to it. So like on this first one, x squared is alone, and it is an x squared, which tells me it's either going to be up or down. And since 6 is a positive number, it's opening up. That's all we're doing here. Just saying up, down, left to right. Okay, the next one, same idea. Since negative 48 is negative, even though this is turned around, like the equation has x squared on the right side, still okay. As long as x squared is all alone, and then it's a negative, that means this is down. So x squared with the negative number is down. Now we get to the left and rights. The first one is y squared with a positive 4, so this is right. And the last one is, although it looks like it's right at first, the problem is I can't have anything extra when I have a y squared. So I have to move that 20x over by subtracting it. So I have y squared equals negative 20x, because 0 minus 20x is just negative 20x. Now looking at it, it's got a negative, and it's a y squared, so it opens left. All right, that's pretty much it for the direction it opens. Now we move on to, there's two more things we're going to get through, and we're almost done here. For the equations that we saw so far, I'm going to go ahead and rewrite them from the front page. They were x squared equals 4py. That's like the generic form of every parabola equation that opens up or down. And y squared equals 4px. Same idea, but for ones that open right or left. Well, there's this p in there. And again, p is the distance from the vertex to either the focus or the directrix. So we need to sometimes find p so that we can then get into graphing them or trying to figure out something, what else to do, right? So that if you just are given an equation like this, we should be able to find p. So the main idea here is if it's got a y squared, then you look at the number on the other side and say, okay, the negative 12 here. I have to take negative 12 and set it equal to 4p, because remember, that's part of this equation. The 4p part is negative 12, and so to solve here, we would divide by 4. And p would come out to negative 3. And that's all we're doing over and over again for the next few examples. So the only difference is you have to make sure your x squared or your y squared is isolated before you go and divide by 4. So like letter B here, we take that 4, since x squared is isolated, and we do 4p equals 4, or just divide by 4. If you don't need to show this work, you don't have to. I'm just showing it here so you can follow along and see where it's coming from. The main idea, though, is that we're just dividing by 4. And whether you do that on a calculator or in your head, that's up to you. The next one, though, is a little tricky. Because there's no number there in front of the x, it's just a 1. And so I still have to divide by 4, though. So it's still 1 equals 4p, and then I divide by 4. So you do get a fraction or a decimal here, 1/4. And that will happen sometimes. So sometimes your p-value will be a positive number, a negative number, a decimal, or a fraction. Same idea on D. You're going to get another decimal here because 10 equals 4p means just divide by 4. Comes out to 2.5 that you can write as a decimal or a fraction. Up to you. Improper or mixed fraction, it's up to you. But the last two, E and F, are a little different because they're not completely isolated. Y squared has that negative 16x still there, so I need to first add 16x before I can decide is it what p would be. So now I have y squared equals 16x, and I can take my 16 and divide by 4. So again, if you need to show work to do that, go ahead. If you want to just write it, 16 divided by 4 is 4. That's fine too. Alright, so then that p is just 4 again. If you need to show the setup, 4p equals 16, and then divide by 4, go ahead. Or if you just want to show, I got this, I'm going to divide by 4, get my answer, that's fine too. Alright, the last one though, if you try to divide negative 1/8 by 4, first of all, that would just be a kind of a crazy fraction. But really, I don't want to do that because my y squared is not alone. I need to actually move this negative 1/8 to the other side. And so I have to do the reciprocal, or multiply by negative 8. So that's why, to get rid of it on the right-hand side, that's how I will get y squared alone. So now, y squared is alone on the right side, and I have negative 8x. Now it's in the right form, and I can find p by dividing negative 8 by 4 to find p. And this one comes out to negative 2. Alright, so again, main objective on every single one of these, divide by 4. But the reason you're doing it is based off the equation, in case that wasn't clear. Alright, we're going to finish up with just one last piece about something you've seen before in Algebra 1, and or maybe even earlier this year, where there are some things are functions and some are not. We've mainly been studying functions since the beginning of the year, with all the families of functions. We haven't done too much with non-functions. But now, parabolas that can open left or right, we're going to see are not functions, and here's why. There's something called the vertical line test. What you do is, it says in order for a relation to be a function, it must pass the vertical line test. And if vertical lines, basically to do this test, you draw a vertical line through the graph at any place you want. You could draw a bunch of them, or just one. If it only hits the graph at one point, then it is a function. If you draw a vertical line or a bunch of vertical lines, and the graph passes through, it hits the graph at more than 1 point, so it could hit it twice, 3 times, 4 times, whatever, that means that it is not a function. So when I think of specifically with parabolas that open up or down, if I try to draw like a vertical line anywhere at all, and I can draw a bunch of them, it always just hits it once. And I could do a bunch of them. But if I try to draw my parabola to the right or to the left, and then I try to draw a vertical line, it hits it twice. So that's what makes this second one not a function, and the first one is okay as a function. That's why when we first studied parabolas, we only did functions, and they had to open up or down. Now we're looking at all 4 directions, and so the ones that will open left or right, not functions. All right, so we're just going to go through this bottom part here. We're just going to draw vertical lines and see how many times does it hit. You can draw them anywhere you'd like, so I could do it here, and I notice it hits it 3 times on the graph. Right, so wherever you want to do it, or draw it anywhere at all. But if it's possible for it to hit it more than once, then you want to draw it in that spot. So this comes out to not a function. Because again, it hit it 3 times. Whereas B, when I go to draw any vertical line here, or you can basically do it anywhere, I could do it right in the middle even, it always hits it once. So this is a function. C is the same idea, although it kind of looks like it's similar to the shape on letter A. It's more like stretched out, and so nothing is stacked on top of each other. No matter how I draw my vertical line, it only hits it once. So this is a function again. It's kind of a cubic type function. The last one's a circle, and a circle is not a function because no matter what, when I draw it pretty much on almost every spot, it hits it twice. So that's not a function. You can also just write yes or no if you don't want to write it all out. The last two are not graphs. You could do a graph if it would help you to understand if it is or not a function, but my parabola opening right, like I did above, is not a function because when I draw the vertical line, it hits it twice. So that's not a function. Whereas the last example, it just gives me an equation. You have to figure out which way it's opening to help you decide is it a function or not. Since it's an x squared with a negative, it's upside down. It's an opening down parabola. Those are okay though. No matter where you put your vertical lines, always just hits it once. So it is a function. All right, and that's pretty much it.